Okay, so this is where we left off. I'm just going to do a couple just to get us refreshed. Let's take a look at the first one. The square root of 32. Remember, we're looking to factor, guys, listen up, please. You're looking to find perfect square factors. So here's a few of them to get you started. Perfect square factors that might divide 32, and then we can simplify. So like if you take a look at these possibilities, both 4 and 16 divide 32. So you have two possibilities. You can say, okay, square root 32 is the same thing as square root 4 times square root 8. And that square root 4 would simplify to a 2. How many of you guys have 2 root 8 on your page? So unfortunately, 2 root 8 won't get you the full mark if you're doing this on a test. There's a better answer, and that would be the square root of 16 times the square root of 2. And the square root of 16 simplifies to 4. So while both are kind of correct, one is better than the other. Okay, so you're going to want to always check for more simplification. Okay, always check for more simplification. Like if you take a look at the one that I said isn't quite correct, this one here, the 2 root 8, what could you do with the root 8? The root 8 you could say would be what? Square root 4 times square root 2. And then that square root 4 becomes 2. And then 2 times 2 is 4, which is the same as this one. So make sure that when you're doing this, that you go fully simplified. And then how can you just like make sure you're going to do that in the first place? Is just if you have a possibilities where you could choose more than one, you just want to choose the larger. Choose the large one. Choose the larger option. And then you don't have to worry about it. Like for 48, 4 works, but is there a better one? But choose 16 instead. That's 16 times 3, right? Both radicals, and then the square root 16 is perfect, so you get 4 root 3. So that's where I left you guys off. That's what we did last day on Friday. So let's take a look at one. Let's take a look at a couple of these. Let's take a look at 12. 75 could be rewritten as 25 times 3. Why do I choose 25? Like, why don't I choose something else? Like, why don't I try like 5 and 15? Like, is 5 times 15 also 75? Is that true? So why don't I choose those two? Why do I choose 25? What's special about 25? It's a perfect square. So I can simplify perfect squares. If I try to do like root 5, root 15, both of those are non-perfect, so it gets me nowhere, and there's no point in doing that. So you always just choose perfect square factors. What's the square root of 25, by the way? So then you have 2 times 5 times root 3. This one's 10 root 3. You guys okay with that one? Now for the last one, 2 root 100. Sometimes people get this one messed up. They're like, the square root of 100? That's perfect. What's the square root of 100? Just 10. So you get 20. So it's not like you have to do this method all the time. Like, square root of 100 is perfect, so you can just simplify it. Okay, so be on the lookout for perfect ones that are already there. Now we're going to go the other way. We're going to go from mixed to entire. We're going to do what we talked about yesterday, but in the opposite direction. So for me, like I can't really think of a reason that I would want to do this. Like why would I want to go from mixed to entire? It's like there is no reason to do this. Personally, I don't think that there's a reason for this. But it will help you, however. It helps for like in math, like there's always like a forward and a reverse process. So this like forward, reverse processing. So what do I mean by that? Like if I add 5 and then subtract 5, does that sort of undo each other? So that's what's happening here. If I go from the mixed radical and then back to the entire radical, so it's like a forward and reverse processing. It's just good for that understanding. So 5 root 7. Like if I was doing a math question that had nothing to do with radicals, but that was involved, I'd be so happy with 5 root 7 because it's fully simplified. This is good. This one makes me happy. 5 root 7, like that's a good thing. But for some reason, we're going to go to the entire just to see how it works. So what we're going to do is we're going to have to imagine, like, what would 5 look like inside the radical? What would 5 look like if it went in there? What's 5 times 5? It's because, remember, it's the opposite of square root. Like, what square root took place that you ended up with 5? Square root of 25. So that's, I did like a substitution. I replaced 5 with square root 25, and now I can put the numbers together inside the radical, and 25 times 7 is 175. So it's just the reverse process of what we've been doing. Any questions about that? So again, it's just for number sense. I'll leave that on the side. Okay, now the next one is a cube. So I'll just redo the first one a different way. 5 root 7. When I put the 5 on the inside, I'm just going to square it. And then I get the 25 times 7. Same thing. You guys okay with that? So why is it okay to go from 5 to square root 25? Because it's just 5 squared. The square and the square root are like forward and reverse processing. Square to go there, square root to go back. What's different about this one, though, is not a square root, it's a cube root. So when I go to replace this 2, I want to replace it with its cube. So how did I know it was 8? Well, I've been doing this a while and I got that one memorized. But for you guys, you don't have that memorized. How do you know it's 8? Good. You can put the 2 cubed inside the radical house next to the 5. So like, what would this 2 look like if I put it inside there? Well, I would have to attach a power 3 because the cube root and the cube would undo each other. And then I can simplify this. 2 cubed is 8. 8 times 5 is 40. And don't forget this whole time that you gotta have the little radical sign, cube root. Okay, so you go from this guy, which is the mixed, to this guy, which is the entire. Mixed to entire. Mixed has the coefficient on the outside, entire doesn't. So you guys can try these ones underneath. You guys try these ones. I'll leave the notes up though. You try those two underneath. Alright, so we talked about it as a class. But when the 3 goes inside, it gets the square. Guys, can you please stop talking? And then you end up here. So everyone was okay with that one? Why isn't that thing showing up? There it is. Okay, so the big idea here is when the 3 goes inside the radical house, it gets the 3 squared. Because it's just 3. Like 3 is 3. When it's inside, it's like crossing another dimension. It becomes 9, which is 3 squared. How about the other one? We talked about this as well. When the 6 goes in, it goes in as a 6 cubed because we're doing cube roots. Not showing up. And then do exponents. Do your exponents before you multiply. So 6 cubed is 216. 216 times 3 is, help me out, what you guys, 648? So that's what you're looking for, the cube root of 648. Make sure when you're writing this that the 3, the little index, is quite small. It should be very clear that the 3 is smaller than the way you write the 648 so that the reader has a good chance of understanding what the heck you're talking about. Yeah, it should be small and off to the side. Okay, so these I'm going to leave as exercise for you guys. So this is for you guys. 1 to 10 is for homework. I'm just going to do these ones underneath first. And then I think today we're going to give you guys a quiz at the end. Quiz at the end today. End of the class quiz. Because we didn't do a quiz last to start the, because I spent 2 days on one lesson. So it's kind of like an exit slip. Okay, let's take a look at this Pythagorean question. So do you see how this is just a right triangle and they're going to ask us to find this guy right here, this xy? That's all they want us to do. So when we go to use the formula for Pythagoras, this one up here, c squared equals a squared plus b squared, we just have to plug into the right spot. I think most people are comfortable with this. So you have 19 squared equals 5 squared plus, let's call it b, I guess, b squared. And let's solve for b. Let's solve for b. How would we solve for b? We got to move the 5 to the other side. You guys okay with that? So minus 5 squared minus 5 squared. And you can just figure those out. Help me out. What's 19 squared? Someone do that one for me. 19 squared. 361. Take away 25, and that'll be equal to the b squared. So subtracting that, what do you get? 336 equals b squared. So then how would we solve for b? Square root both sides. And that would be how you were trained forever, like in your junior high when you're doing this type of material. So you would get a decimal for this. They want the decimal to the nearest hundredth. Please find the square root of 336 to the nearest hundredth. Should be bigger than 5 but less than 19. 18.33. What's the third decimal? Oh, so it's easy to round, hey? So that covers this one. Decimal to the nearest hundredth. How would we cover the first one? The entire radical? Well, That's just the square root of 336. So box 1 and box 2, they cover I and triple I. But how would we cover the second one, the mixed radical? What would we have to do to this 336? We would have to do what I taught you guys on Friday. So I'm going to start it up here. The square root of 336. I need values that are perfect squares that divide that. So what's the first one you should try? 336 divided by 4. Does it work? 336 divided by 4? It works. What are you left with? I wonder if inside 84 there's another square that could divide 84 by. I bet you could divide that by 4 again, hey? It's 21. So let's see. I got on my whiteboard here 336 divided by 4. I got 84. Then I divided by 4 again, and I got 21. Inside the 21, are there any perfect square factors? Inside 21? Is there a perfect square that divides 21? 4 doesn't work, 16 doesn't work, 9 doesn't work. So the 4 and the 4, what if you put those together? That would be 16. I bet 16's the best choice. 16's the best choice for your perfect square factor. Perfect square factor of 16. So let's try that. What's 336 divided by 16? 21. So you have root 16, root 21, and the root 16 becomes 4. And that box would cover double I. So check mark for double I, mixed radical, for root 21. Okay, so for the next 20 minutes or so, you're going to work on 1 to 10 up here, and you're going to try A, B, and C. And then when that's all done, you can finish off this assignment. And I'll walk around handing back quizzes and helping out.